This is one of the Burger King questions that became very popular recently. So the question is based out of two main concepts. One is the summation and other is the factorial. So let's try to solve this question stepwise. Let's try to understand each and every part of it. And at the same time, let's try to understand what do we mean by summation and what do we mean by factorial in order to solve this question. So I have written down the question here. You can see the entire question written here. So first of all, let's try to solve this green portion that I have marked here. Let's try to solve this part. So the main concept in this part is this denotion, this factorial thing that you can see here. Some of you may already know it. Some of you might be learning this for the first time. So basically what this factorial means is that, for example, let's say that we have 5 factorial. So 5 factorial would mean that I have to multiply all the natural numbers from 1 till 5 to get the value of 5 factorial. Similarly, 4 factorial would mean multiplication of all the numbers from 1 to 4. Similarly, for example, 10 factorial would mean multiplication of 1, 2, 3, 4, 5, 6, 7, 8, 9 until 10. This is a simple meaning of factorial. We'll play more with this in your higher grades, but as of now, this definition, if you are sure with this definition of factorial, we are good to go for this question. So now let's take down this part and let's try to solve this. So this part I have written here, 5 factorial times 5 divided by 4 factorial whole to the power 1 by 2. So this 5 factorial would mean 1 times 2 times 3 times 4 times 5, as you can see here. This 5 we have written down as it is. 4 factorial, this 4 factorial means 1 times 2 times 3 times 4. So on dividing both numerator by and denominator by 1, 2, 3 and 4, these 4 terms on numerator and these 4 numbers in the denominator would cancel out each other, and we would only be left with 5 times 5, that is 5 square in the numerator. Now here we have 5 square and whole to the power 1 by 2. Now when we have something like this, a to the power m times n, or rather I would say a to the power m whole to the power n, the powers get multiplied with each other. So that's why we have multiplied 2 and 1 by 2, and finally the value is equal to 5. To learn more about how these power works, you can just refer to your chapter powers and exponents to actually understand why is this happening. But as of now, we'll just go with this, that we'll multiply these powers, and 2 times 1 by 2 is basically 1. So 5 times 1 is basically 5. So we have solved this part. The value of this part is 5. And our this equation, this left hand side of the equation that we want to solve, this now reduced to this thing. Instead of this entire value, we just substituted with 5. So finally we have summation of I equals to 1 to 461, and there is a negative sign outside, don't forget that. And we learn now what is the meaning of this symbol summation. It may look scary at first, but trust me, it's very simple. We'll learn this together, don't worry. Times negative 1 to the power I times 5. Now as you can see here, it's written that this means summation, or in simple words, in simple terms, we can call this addition. But how is this different from normal addition? So here you can see there is a variable, this I. This I varies from 1 to 461. So this summation, this sign would mean that I have to start with a value of I equals to 1 and end this at I equals to 461. So we'll start with I equals to 1. With this entire expression, we'll first substitute I equals to 1, write this entire expression, add another expression with a value of I equals to 2, then add another expression with a value of I equals to 3, and so on until 461. So let's see how this equation would turn out to be. So yeah, so first of all, we started with I equals to 1. So this equation would now change to negative 1 to the power 1, as you can see here, and times 5 would come as it is, because there is nothing that includes I here. So this 5 we would write as it is. Only the difference that would come is in this power, because we have I here. Since I starts from 1 and goes on to 461, we started here negative 1 to the power 1 times 5. This is for I equals to 1. Similarly, when I would be equal to 2, we would get negative 1 to the power 2 times 5. This is the value when I is equal to 2. Similarly, we have negative 1 to the power 3 times 5. This is when this is the value of the expression when I is equal to 3, and this would go on and on and on. This is for I equals to 4. This would go on up to 460, and then finally to 461. So this is the expression that we need to solve to find the value of this thing. That would give us our final answer. And just make sure that you remember that we have a negative sign outside this entire thing. So basically, whatever the value of this thing is, we have to take negative value of that. Okay, so now one thing that we can see here, one common pattern that we can see here is that this 5 is a common factor of all the terms. We have 5 here, 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 here. All the terms have this 5 as common factor. So we can pull out 5. So this would make this expression look very simple. And when we would take out this 5 outside, all these 5s we can take it out because 5 is the common factor. So we can take out all 5s, and inside we would be left with negative 1 to the power 1 plus negative 1 to the power 2 plus negative 1 to the power 3 plus negative 1 to the power 4, so on, up to negative 1 to the power 460 plus negative 1 to the power 461. So now this is the final expression that we have to solve. And I hope things are clear till now. And let's see now how we can solve this. So there's a small concept that is involved here. And the concept is that negative 1 to the power odd number would give me negative 1. This would mean that I have to multiply negative 1 with itself odd number of times, which would finally give me negative 1. And negative 1 to the power any even number would give me positive 1 as the final answer. This would mean multiplying negative 1 even number of times, which would finally give me positive 1 as the answer. For example, let's say that we had negative 1 to the power 5. This would mean that we have to multiply negative 1 5 times. So this one pair, negative 1 times negative 1 is 1. This negative 1 times negative 1 is 1. And this negative 1 would be left out. We would have this as it is. 1 times 1 is 1, and this negative 1 would come as it is. 1 times negative 1 is negative 1. Similarly, now let's talk about even power. Let's say that we have negative 1 to the power 8. So this would be our first pair, which would give us 1. This would be our second pair, which would give us 1. This would be our third pair, which would give us 1. And this would be our fourth pair, which would give us 1. So 1 times 1 times 1 times 1 is actually equal to 1. So in even powers of negative 1, all the even number of pairs, we have even number of equal pairs, and they combine together to finally give us a value of positive 1. But in odd pair, we have even number of pairs plus an extra negative 1. This negative 1 multiplies with all the even pairs, which actually give us 1. So finally we would have 1 times negative 1, which would finally give us negative 1. So as a matter of fact, we can just use this part that negative 1 to the power odd number is negative 1 and negative 1 to the power even number is positive 1. Let's use this concept to solve this final equation. So this is the expression that we were talking about. Now negative 1 to the power 1, we have an odd power, so its value would be negative 1. Negative 1 to the power 2, we have an even power, so this would be positive 1. Negative 1 to the power 3, again an odd power, so this would give us negative 1. Negative 1 to the power 4, again we have an even power, so this would give us positive 1. So we are getting alternate plus 1s and minus 1. Negative 1, positive 1, negative 1, positive 1, negative 1, positive 1. And finally, negative 1 to the power 460, again an even power, so this would give us positive 1. And negative 1 to the power 461, odd power, so this would give us negative 1. So basically, we have equal number of even pairs and an extra negative 1 at the end. So negative 1, positive 1 cancel out, negative 1, positive 1 cancel out, negative 1, positive 1 cancel out. Similarly, the negative 1 that would be coming just before this positive 1 would cancel out each other. So we would be only left with negative 1 finally. So now we have negative 5, this negative 5 multiplied by only this negative 1 is left inside. So we would have this negative 1. Negative 5 times negative 1, multiplication of two negative values would give us a positive value, that is positive 5. So 5 would be the answer to this question. So I hope you understood how did we solve this question, and equally important is the concept that behind solving this question. What is the meaning of summation, what's the meaning of factorial, and if these things are clear, so with some amount of patience and keep trying this out, to finally actually understand that 5 would be the solution of this given equation. Thank you.